Good morning, everyone. Chief and Wrigley are hanging out with me in the room, so hopefully you don't hear any barking, or Wrigley is currently trying to get me to pet him, so hopefully you don't hear him whining. But anyways, today we're going to continue our Pythagorean identities, or just our identities in general, and today they're going to be the Pythagorean identities. Hopefully that rings a bell with the Pythagorean theorem. It's very similar, and we can actually derive trig identities because of the Pythagorean theorem. So first of all, we're going to kind of combine the next two parts together. So remember that we can say x squared plus y squared equals r squared. And then remember that sine is the ratio of y over r, and then cosine is the ratio of x over r. Okay, so using that, we can do x over r squared plus y over r squared equals 1, because remember that on the unit circle, r equals 1. So then go ahead and simplify this. Okay. And then we're going to multiply everything by r squared. And we get x squared plus y squared equals r squared. Therefore, sine squared theta plus cosine squared theta equals 1. This is a very popular Pythagorean identity that we use. So to think of the Pythagorean theorem, sine squared plus cosine squared equals 1. All right. So using that, we're going to go ahead and take a look at these examples. So example number 1 is taking sine squared plus cosine squared of the angle pi over 6. So sine squared of pi over 6 plus cosine squared of pi over 6. Does that equal... Sorry, I was trying to make a question mark there. Does that equal 1? Okay, so pi over 6 is a 30-degree reference angle, so this is 1/2 squared plus root 3 over 2 squared. So that's 1/4 plus 3/4, so that's 4 over 4, which does equal 1. Well, hopefully that didn't scare you too much. So Chief and Wrigley, I kicked them out of the room. All right, so let's go to the second one. So we're going to do the same exact thing, but for pi over 4. And does that equal 1? So that gives me root 2 over 2 squared plus root 2 over 2 squared. So 2 over 4 plus 2 over 4. And once again, that equals 1. All right, let's go to the third angle, which is pi over 2. And we're going to plug it into the Pythagorean identity. Okay, so at pi over 2, it is going to be 90 degrees, which is 0, 1. So 1 squared plus 0 squared equals 1. That one's fast. And then the last one, we're going to do this for pi. Notice that the unit circle is over to the right for you. So at pi, it's -1, 0. So this is going to be 0 squared plus a -1 squared. so that equals 1. So no matter where we go on the unit circle, sine squared plus cosine squared will always equal 1. All right, let's go to the next page. Okay, and this page is actually, we talked about this yesterday, that this page is actually at the end of your notes. So make sure by the time that we are done with today's lesson that you go and fill in the Pythagorean identities. Okay, so once again, remember that this page is at the end and you're going to do this when we're done with the notes. All right, so first thing up is we're going to take sine squared plus cosine squared equals 1, and we're going to do a little manipulation of it so that we can use these identities to verify later on. All right, so this is the Pythagorean identity. And I forgot to write the angles in there. Okay, and then if I want to solve for cosine squared, okay, then I'm going to go ahead and subtract sine squared from both sides. So this is a manipulation of the Pythagorean identity, which states that cosine squared theta equals 1 minus sine squared theta. Okay, now continuing on this note, sometimes you might see this reversed. It might be manipulated a little bit differently, and instead you might see a negative cosine squared theta. If that's the case, then it's sine squared theta minus 1. So all I did was take, if I made this negative, then that means I had to divide the right side by a negative 1. And when dividing by the right side of negative 1, this would be negative 1 plus sine squared theta, and then all I did was flip the order. Okay, so you have to be able to, when you're working with Pythagorean identities, you have to be able to recognize all the different manipulations. So we're going to go ahead and do the same thing for sine squared theta. So here's the original. Okay, and then we're going to subtract. So then we get sine squared theta equals 1 minus cosine squared theta. And then we're going to do the other manipulation over here, where if we make sine squared negative, then the other side flips around with the negative signs. Okay, so you need to make sure that you pay careful attention to the particular orders, because it'll dictate if it's going to be a positive sine squared or a negative sine squared, and same thing with cosine squared. All right, dividing by cosine squared. So let's start off with the original. And then we're going to divide everything by cosine squared theta. So we get tangent squared theta plus 1 equals 1 over cosine squared theta. So this is actually another Pythagorean identity. Okay. So we have tangent squared plus 1 equals secant squared. So you will see this on your Pythagorean identity sheet. And then, of course, a manipulation of this would be tangent squared theta equals secant squared theta minus 1. And then we could also make that a negative tangent squared, which means the signs on the right-hand side would flip. Okay, and then the last one we have is sine squared. So starting off with the original, and we're going to divide everything by sine squared theta. So we get 1 plus cotangent squared equals 1 over sine squared. So 1 plus cotangent squared equals cosecant squared. So a lot of times students mix up these two, the ones that are highlighted in blue currently. The way that I always remember it is that the reciprocal c's go together. So cotangent and cosecant go together. So then tangent and secant go together. Okay, so the reciprocals, the c's go together. All right, and then we got to do our manipulations. So cotangent squared equals cosecant squared minus 1. And then we could also flip this, and we get 1 minus cosecant squared theta. Okay, so make sure that you primarily know the big three ones. So the big three are obviously sine squared plus cosine squared equals 1. And then these two that are highlighted in blue. Okay, now granted, you can find all of these based off the original. And then of course, notice that, know the manipulations. Okay, so we're going to use the manipulations a lot. So you got to be able to recognize that if you have one of these trig functions squared, that you might need to be using a Pythagorean identity if there's a +1 or a -1 in it. All right, let's go to the next page. So the first thing we're going to do is just use a Pythagorean identity to solve equations. And actually, before we even start, we need to change this problem. And instead of having it be equal to -√2/2, we're going to have it equal to 1/2. Okay, the reason why is because if we go to try to take the square root, we're not going to be able to take the square root of a negative. So please flip that to 1/2. All right, so to get started, let's look at the left-hand side, see if we can manipulate anything or substitute an identity in. Okay, notice that we do have a -1 in there with a function that's squared, so you should be thinking some type of Pythagorean identity. So here's where we're going to have one of those identities. And then off to the side, the identity that has cosecant squared in it is 1 plus cotangent squared equals cosecant squared. Okay, so notice that this is going to be a manipulation where cotangent squared equals cosecant squared minus 1. So we are going to substitute in cotangent squared. Okay, so now we have sine squared times cotangent squared, and we're going to use our reciprocal identities from yesterday. So sine squared times cosine squared over sine squared. Okay, this will allow the sine squareds to cancel out, and we're left with cosine squared equals 1/2. To solve this, we're going to take the square root. Remember that with square roots, you have to remember plus or minus, and the square root of 1/2 is just going to be √2/2. Okay, at √2/2, we don't have to worry about any of the reciprocal identities being undefined. Remember that you only have to worry about that at the quadrantal angles. So then we're just going to identify all the angles between 0 and 2 pi, with 2 pi not being included, where cosine equals √2/2, and that's going to be all of the 45-degree reference angles. And there's your final answer. And as always, you guys can plug it back in to double check your work. All right, let's go ahead and take a look at number 2. Sometimes the hardest part about these problems is just figuring out where to start, where to go from here. So if we look at the equation on the left, we don't really see, like a Pythagorean identity doesn't really pop out at us when we first look at it. So we're going to try to see if we can manipulate it somehow so we can get a Pythagorean identity. And notice that this equation does have a factor in both terms. That's common. So we're going to go ahead and factor that sign out. Okay, and now hopefully you recognize the fact that, sorry, I didn't know that was going to completely highlight over it, but that this is a Pythagorean identity, which just equals 1. So now we have sine x times 1, which is just sine of x, equals root 3 over 2. And from there, where does sine equals root 3 over 2? That's going to be at your 60-degree reference angles in quadrants 1 and 2. Okay, let's go ahead and take a look at the next example. This is going to be one of the tougher of the problems due to the fact that because of just how we have to manipulate it. So notice that we have a linear function in here. It's just a cosine, and we have a sine squared. So when that happens, we can't factor out a GCF. We can't use a Pythagorean identity because this is not squared. Remember that the Pythagorean identity only applies for when they're squared. So like sine plus cosine doesn't equal 1. It has to be sine squared plus cosine squared. Okay, so when that happens, you actually want to change, if you can, the trig functions all into the terms of the same trig function of the linear term. Okay, I'll say that again because I know that was a lot. So if we can't factor out a GCF, then change in terms of the linear function. So in this example, the linear function is cosine. So can we change sine squared to be something in terms of cosine squared? Well, for sure. If we have our trig identity here, we can isolate sine squared and make that equal to 1 minus cosine squared. Okay, so that's what we're going to go ahead and substitute in. So we have 2 and then 1 minus cosine squared. Remember that we are replacing what's underlined in red. Minus cosine x equals 1. Okay, now I have everything in terms of the same trig function, and I can go ahead and start solving. So 2 minus 2 cosine squared minus cosine x equals 1. So this is going to be a problem that I actually have to factor. And as always, you know that I like to keep the leading term positive, so I'm going to move everything to the right instead. So I get 0 equals 2 cosine squared plus cosine x minus 1. Okay, we can't do the quick factoring here due to the fact that a is a number greater than 1, so you can do the factor by grouping, or notice that the factors are pretty small here. So I could just use guess and check. So 2 cosine x minus 1, cosine x plus 1. Okay, and then set each factor equal to 0. And notice that this is very similar to last chapter once we apply the Pythagorean identities, or whatever identities that we're using. Okay, so cosine x equals 1/2. That's going to be 60-degree reference angles in quadrants 1 and 4. So, 60-degree reference angles. So pi over 3 and 5 pi over 3. And then cosine equals -1 at pi. So here are my angles in order. Okay, so we have one more page of notes. Sorry, I know this is a long lesson, and I know it's not as simple listening from a video as in person. But let's go ahead and take a look at the last slide. And the last slide is dealing with verification. So Like we talked about yesterday, verification is not like solving equations. We just work on one side of the equation and we try to manipulate it to be the right-hand side, okay? It's like a little puzzle. Okay, and remember to always assume that I know nothing and that I don't know any of the trig identities, so you can't skip steps. You got to show me everything. This is like a proof. Okay. So we're going to take a look at the left-hand side and notice that we can use the reciprocal identities from yesterday to change 1 over secant squared. So we have sine squared beta plus cosine squared beta. And lucky for us, this is a Pythagorean identity. So 1 equals 1. I write my verification statement, which is the right-hand side, and I'm done. Okay. All right, let's go ahead and take a look at number 2. For number 2, we don't see a Pythagorean identity that jumps out at us right away, so we're going to try to manipulate things if we can on the left, which we can change and use the reciprocal identities from yesterday. So I'm going to change tangent squared. Okay. So then our cosine squareds cancel out. And I have sine squared minus 1. So now this is not a Pythagorean identity, the basic one that we're used to seeing. This is a manipulation. So I'm going to go ahead and include that in my work. Because remember that we have to assume nothing. Okay. So if I solve for cosine squared, notice that it does not look identically the same. And notice up here on the right-hand side, I want cosine squared to be negative. In here, cosine squared is positive. So this is one of those manipulations that I'm going to change all of the signs. And now I can go ahead and say that this equals, from up top, this equals negative cosine squared x. And then I can write my verification statement. Okay, so once again, assume nothing. Got to show all of your work. Might not be the manipulation right off from the get-go, and you might have to change all of the signs. Okay, we're getting closer. We've got 3 left. So let's go to number 3. Once again, there is nothing that pops out at us that's a Pythagorean identity right away, but notice that we can factor a cosine squared out of the left-hand side. Okay, remember that we do not want to divide by cosine squared. This is not like solving equations. We strictly just work with one side of the equation, just one side. Okay. Hopefully we recognize that that is a Pythagorean identity. It equals secant squared. Okay. And then I'm going to use my reciprocal identities from yesterday to change this to be 1 over cosine squared. The cosine squareds cancel out. It equals 1. And I write my verification statement. All right. Let's go to number 4. So we're just going to strictly work with that left-hand side. The denominator is nice. That's going to be a trig Pythagorean identity right out from the gate. It's just going to be cosecant squared. Like we talked about yesterday, knowing the identities, the faster you get them memorized, the better that this is going to be for you. So you want to be able to pick these out right away and go, oh, there is a Pythagorean identity, and recognize it, okay? But until you memorize these, it's kind of hard to recognize it right away, okay? We do have a manipulation of 1. So 1 plus cotangent squared equals cosecant squared. But I need cosecant squared minus 1. So I'm going to go ahead and manipulate it. And now I can continue on with my verification. So we have cotangent squared over cosecant squared. Use the reciprocal identities from yesterday. So we have cosine squared x over sine squared x, all divided by 1 over sine squared x. Remember that when you are dividing fractions, you multiply by the reciprocal. So now I have cosine squared over sine squared times sine squared. These cancel out, and I'm left with cosine squared, which is exactly the right-hand side. And I'm going to write my verification statement. So make sure that we are showing all steps. Okay, remember that this is part of being graded is your work and showing the proof, because that's what this is. All right, one last example. So we have a manipulation. So normally we have 1 plus tangent squared equals secant squared. And we're going to go ahead and subtract the 1 from the other side. So this equals tangent squared theta. Okay. All right, so let's go ahead and change that over. Okay, and then reciprocal identities from yesterday. Okay, and then when you divide fractions, you multiply by the reciprocal. And then the next step, I'm going to change tangent squared also using the quotient identities from yesterday. So tangent squared is the same thing as sine squared over cosine squared. Okay, and remember that when you cancel, the ratio has to be 1 to 1. So 1 in the numerator, 1 in the denominator, and voila, equals 1. And I have my verification statement. All right, give yourselves a hand. That was a long lesson, I know, but nice job. Okay. Obviously today's the day of the surgery, so not sure what I'm going to be, how I'm going to be feeling. But if you guys do have questions, email me. And then on a Thursday, I plan on FaceTiming before your guys' quiz, which is on Friday, so I can answer any of your questions. All right. Hope you all have a wonderful day. Help each other out like you guys always do, and enjoy your Tuesday. Thank you.